Today we are going to see rectifiers. Rectifier is a device that is used to convert alternating current to direct current. So in 10th standard we have seen what is the difference between alternating current and direct current. Now we can represent the difference by a graph. So in this graph we can see here this is the time and this is voltage. We can see alternating voltage continuously change the direction. This is alternating current. And now for direct current, the graph will be almost steady. If this is a voltage, the graph will be steady. Means this is called a direct current. Direct current has same direction throughout. It will not go to negative side, only positive side like this. From positive to negative, continuous current. This is the DC and this is AC. That's the difference between AC and DC. Now, rectifier is a device which can convert AC to DC. Now, a rectifier mainly consists of a transformer. A transformer is used to either reduce the voltage or to increase the voltage. Here we use a transformer which is known as step down transformer. So we have a step down transformer we have to use here. So we have two types of rectifiers. One is half wave rectifier and other one is full wave rectifier. So for a half wave rectifier we use a step down transformer. Okay, so we will draw the diagram. We have the transformer. This is the I am drawing the primary of the transformer. Primary has large number of turns because it is step down. And this is a voltage, that is VI, the input voltage, input alternating voltage. These two lines represent core of the transformer. Then we have secondary has less number of turns. Why? Because it is step down. Now these are the two terminals of the transformer. Here we will connect a diode. This is a diode, a PN junction diode. Then we have a resistor. This is a load resistor and it is connected to this point. I can mark as RL. So at terminals I will mark these two terminals. This is terminal A and this is terminal B. So this represents the transformer, this region. Okay, I can mark it as transformer. This is a step down transformer. The step down transformer consists of primary and this is secondary. This will produce a low voltage here. This is a large alternating voltage at the primary. At secondary we will get an alternating voltage of small magnitude. So that's the use of step down transformer. Now we can see two terminals A and B. Now before that I will draw the input, variation of input signal, variation of the input voltage. I will draw the variation input voltage like this. So I will represent the voltage variation. This is a voltage. This is a positive half cycle, negative half cycle, again positive half cycle, negative half cycle. This is a time. Okay, this is input. In the same graph I will draw the output also. This is the axis for output. Okay. Now, the specialty of the transformer is that we can see two terminals. Output we have two terminals A and B. So the polarity of the alternating current at A and B will be such that when end A is positive, at end A there is positive peak, here B will be negative peak. It will change, it will alternate. When it is negative, this will be positive. When it is positive, this will be negative. So let us consider one positive peak of the input. So first positive peak of the input, let end A be positive. I assume that end A is positive. If end A is positive, what will be end B? End B will be negative. Okay, so during positive half cycle, during this positive half cycle, I consider end A positive, end B negative. Now you can see P side of the diode is connected to positive. Positive means high potential. N side is connected to what? Through resistor it is connected to negative potential. What about the condition of the diode? Across means at one end, that is at P side there is a high potential, N side there is a low potential. So the diode will be forward biased. diode will start to conduct. In which direction current will flow? From positive to negative. In this direction current start to flow. So I can say this will be the direction of current through the load resistor. So current will flow like this. In this direction current starts to flow. Okay, I can mark direction of current through load resistor IL. In which direction? From positive to negative. Okay, so there will be output in a particular direction, that is from positive to negative, and I am drawing the output. So corresponding to this positive peak, we have an output, and this will be the output. Okay, so corresponding to the positive, we have the output. Now, negative peak. During the negative half cycle, the polarity reverses. What happens is this will become negative, and what about this? This becomes positive. Okay. Now what happens is that, so the current flown during the positive half cycle, now end P is negative. P side is negative, N side is positive. So easily you can understand which type of biasing will be there for the diode. It is reverse biased, that is P side is connected to low potential, N side to high potential. Diode is reverse biased. Can it conduct during reverse bias? No. So there is no current, there is no forward current. Okay, no forward current flows, so there is no output, no current through the load resistor. So during the negative half cycle, we can say that the current is 0. Okay, no current during this time. Again, next to positive half cycle, again this end becomes positive, this will become negative. Again what happens? Diode is forward biased, current flows in this direction. Okay, this is a load current. Current in flows in this direction. So again we can draw a pulse like this. Okay. Again negative half cycle. The polarity reverses. A becomes negative, B becomes positive. There is no current. So there is no current flowing. So I can say there is no current in this region. Okay. So we will get alternate pulses. Now we have seen that here we don't have a negative peak. Negative peak is completely cut. Only we have positive peak. Okay, so we can say it is only having direction that is in positive peak. So we can say it is in the shape of a pulse. We are not getting the actual straight line graph, but we are getting pulse like this. But there is no current no current corresponding to negative peaks. Okay, we can say this is called a rectified output. So this is called a half wave rectifier. Why it is called a half wave rectifier? Because we have only half waves. We have only positive peaks. Negative peaks were completely eliminated. That's why it is called a half wave rectifier. Hope that you have understood. Okay, thank you.